Morning students, welcome to the Science 1 class. In this video, we are going to learn about mole, Avogadro's number and percentage composition. First, let's learn about mole and Avogadro's number. You know that 1 dozen is equal to 12 units and a pair is equal to 2 units. For example, 1 dozen eggs is equal to 12 eggs. 1 dozen banana is equal to 12 bananas. And 1 dozen pencil is equal to 12 pencils. Similarly, in chemistry, 1 mole of carbon is equal to 6.02 into 10 to the power 23 atoms. 1 mole of water is equal to 6.02 into 10 to the power 23 molecules. 1 mole of oxygen is equal to 6.02 into 10 to the power 23 molecules. So 1 mole is equal to 6.02 into 10 to the power 23. When we say a dozen eggs, it refers to 12 eggs. Similarly, carbon is an element. It is made of many carbon atoms. Just like a dozen contain 12 units, 1 mole of carbon element contains 6.02 into 10 to the power 23 carbon atoms. Water is made of many water molecules, but 1 mole of water contains 6.02 into 10 to the power 23 water molecules. Oxygen gas is also made of many molecules of oxygen, but 1 mole of oxygen gas contains 6.02 into 10 to the power 23 molecules of oxygen. Once again, I'll say, as 1 dozen is a simple number which is equal to 12 units of anything, similarly, 1 mole is also a simple number which is equal to 6.02 into 10 to the power 23 atoms or molecules. Now, let's learn the difference between relative masses and molar masses. Let's take one carbon atom. You know that the relative atomic mass of carbon is equal to 12 AMU. Similarly, one water molecule and the relative molar mass of water molecule is equal to 18 AMU. Here the unit used is AMU and it's an unfamiliar term. In order to solve this problem, scientists put forward the idea of molar masses. We have already learned in detail about molar masses in the previous video. Gram atomic mass and gram molecular mass are called as molar masses. Let's take the same example, carbon. 12 grams of carbon is known as the molar mass of carbon. In the same way, 18 grams of water is known as the molar mass of water. Here the unit used, gram, is a familiar term. Now let's learn about mole. A simple definition for mole is 1 mole of any substance is equal to its molar mass. For example, 1 mole of carbon atom is equal to 12 grams. Why it is equal to 12 grams? Because the molar mass of carbon is equal to 12 grams. In the same way, 1 mole of water is equal to 18 grams because the molar mass of water is equal to 18 grams. Hence, remember that 1 mole of any substance is equal to its molar mass. Now we will learn what is Avogadro's number. Let's learn this concept in a story format. Imagine that Mr. Avogadro, an Italian scientist, took 1 mole of carbon atoms. You know that 1 mole of carbon atoms is equal to 12 grams. He locked himself in a room and started counting the number of carbon atoms present in 1 mole of carbon. After many years, he claimed that in 1 mole or in 12 grams of carbon, there are 6.02 into 10 to the power 23 atoms of carbon. In chemistry, 6.02 into 10 to the power 23 is known as Avogadro's number. Students, you know that 1 mole of water is equal to 18 grams, and there are 6.02 into 10 to the power 23 molecules of water in 18 grams of water. And 1 mole of chlorine atom is equal to 35 grams, and there are 6.02 into 10 to the power 23 atoms of chlorine in 35 grams. So, we have learnt that 1 mole of any substance is equal to its molar mass, and also it is equal to its Avogadro's number, that is 6.02 into 10 to the power 23 units. Now, we are going to step into the next concept, percentage composition. We are going to learn how to calculate the percent mass of an element, and here we are going to use water to do an example calculation. Usually, chemical substances are written using their chemical formula. For example, sulfur dioxide is written as SO2 and nitrogen dioxide is written as NO2. So, the chemical formula tells us how many atoms are present. You know that water is written as H2O. It tells us that there are 2 hydrogen atoms and 1 oxygen atom. Now, we are going to calculate the percentage by mass of each element, that is hydrogen and oxygen in a molecule of water. To find the total mass of water molecule, you should know the atomic mass of each element, that is hydrogen and oxygen. All elements' atomic mass can be found using the periodic table. To calculate the percentage mass of water, first you should know the atomic masses of hydrogen and oxygen. Okay, can you calculate the total mass for 1 mole of a water molecule? It's simple. Molar mass of a water molecule is the answer for this question. As I said you earlier, in the previous video, we have learnt in detail about the molar mass calculation. Do you remember the molar mass of water? Yes, it's 18 grams. Once again, let's recall how you got this 18 grams. There are 2 hydrogen atoms. Each has an atomic mass of 1 gram. So, 2 times 1 equals to 2 grams. And the atomic mass of oxygen is 16 grams. So, 16 plus 12 is equal to 18 grams. Hence, the molar mass of water is 18 grams. Now, let's calculate the percentage mass of hydrogen and the percentage mass of oxygen. You know, percent means out of 100. To find the mass percent, the formula is mass percentage of an element is equal to mass of an element in the compound by molar mass of the compound into 100. First, let's calculate for hydrogen. Mass of hydrogen in water is 2 grams. So, the formula is mass of the element divided by molar mass. Therefore, mass of hydrogen is 2 grams divided by molar mass of water, that is 18 grams into 100. So, what will be the percentage mass of hydrogen in water? It's 11.1 percentage. In the same way, using the formula of mass percent, you have to calculate for oxygen. But is it necessary to calculate in the same way? We know that the percentage mass of hydrogen in water is 11.1%. As we are calculating the percentage, just we can subtract, that is 100% minus 11.1%, which is equal to 88.9%. Therefore, 88.9% is the percentage mass of oxygen. This is how we have to calculate the percentage mass. That's all for today's class. Students, today we have learnt about mole, Avogadro's number, and how to calculate the percentage composition of a compound. Thank you, students. Have a good day.